Right. So this is the second section of the tube. This is the second section of the tube. Right. So here I just answer question number 11 and 12 only. It means I just answer 2 questions per section. I just want to recall your memory. That's what. Right. The question number 11 asks, the following objects are moving along a smooth horizontal surface. Find their accelerations. The following objects are moving along a smooth horizontal surface. Find their accelerations. Right. Let's give a try here. The mass of the first object is 10 kilogram. The force acting on it is 20 Newton. So we just apply F equals MA. The force is 20, mass is 10, acceleration is simple A. By cross multiplication, I can take 10 to the side of 20. So the equation will be simple A only will there, 10 will be at this side, 20 divided by 10. 20 divided by 10 is 2. So we got the answer as 2 equals A, but we should write one more step. We should write A equals 2 meter per square seconds. Please complete this here. This is the answer for question number 11, Roman number 1. Quick. Question number 11, Roman number 1. Complete here quick. Is video clear here? Can you see the board clearly, Lamai?
Yes, sir.
Right. Thank you, dear. Right, shall we go to this second question here? I'll give the answer here. Shall we go to Roman number 2? Right, how many forces are acting on the second object? How many forces? 2 forces. What are the directions of the forces? Are they acting into the same direction or opposite direction?
Same direction.
Then when we say F equals MA, in the equation F equals MA, F is the resultant force. For this case, resultant force is summation of the 2 forces. As forces are acting in the same direction, the resultant force is the summation of the 2 forces. We should indicate it like that. Mass of the object is 12, acceleration is simple E. Can you do the rest and find the acceleration here? Right? So you should remember that in this F equals MA equation, F means the resultant force. F is the resultant force. Got it? F is the resultant force. Do not forget it. Right? Please write here. So here the resultant force is the summation of the 2 forces because they are acting in the same direction. As they are acting in the same direction in this equation, resultant force is the summation of the 2 forces. So 4 plus 2 is 6 equals 12 times 8. So in the next step, we can take this multiplication 12 into the other side as division to it, right? So it will be 6 divided by 12. 6 divided by 12 equals simple. Got it? So 6 divided by 12 is half. So it's very much clear. 6 divided by 6 is 1. 12 divided by 6 is 2. So A equals half. 1 equals 1 divided by 2. 1 divided by 2 means, what's the answer here? Half means, Lamai, 1 over 2 is 0. 10 divided by 2 is 0.5 meter per square second. So this is the answer. Is it clear for clear all of you, dear? Right. So please remember that whenever they have given the equation F equals ma, it means the resultant force. F means the resultant force. In Roman number 2, both forces are acting in the same direction. Therefore, the resultant force is the summation of the two forces. The resultant force is the summation of the two forces. Okay, dear? Right. Shall we go to question number 3? Who wants more time to write the things, dear? Tamal? Right. Let's go to question number 3. Right. For the Roman number 3, for Roman number 3, let me apply the equation again. F equals mv. Right. Now, somebody under the mic can tell me the number of forces acting on the third object here.
2, sir.
2 forces. Are they acting in the same direction or opposite direction?
Opposite.
Opposite direction, sir.
Then what is the resultant force here?
20 Newton minus 60 Newton, sir.
Yeah, minus 6. Bigger force minus smaller force. So what is the resultant force? Very good. 20 minus 16. 20 minus 16 is the resultant force. Mass is 4. Acceleration A. So 20 minus 16 is 4 equals 4 times A. 4 times A. So 4 and 4 cancel out. 4 divided by 4 is 1. Therefore, what is the acceleration? Somebody under the mic can tell me here.
1 meters per square second, sir.
1 meter per square second. Very good. Please try them all. Very good here. 1 meter per square seconds. Complete here. Right. I have discussed question number 11. I want to go to question number 12. Once I discuss question number 12, I will go to another section of the same tube, and I just discussed two questions. So I just want to recall your memory. That's all. That's what I want. Right. Who wants more time to write with answers? Anybody in the class? May I go to question number 12 now? Is the time enough for you to write? Okay, then I'll go to question number 12. I'll erase them all. If you want to take a screenshot, I'll erase them all and I'll go to question number 12. Right, somebody unmute the mic and read question number 12. Start. Somebody unmute the mic and read. I said an object of mass 2 kilogram moving on a raft. What is the meaning of raft here?
It has frictional force.
It has frictional force. That's the meaning. Raft, horizontal surface mean friction forces are acting on the object. That's the meaning. Right. With the constant acceleration of 0.2 meter per square second. So, by a horizontal force of 6 Newton. So, what are the given data? Surface is rough. Surface is rough means there should be friction forces. There should be friction forces. So, first of all, I should mark the friction force. The friction force acting on the object, I have marked into this station. In addition to the friction force, weight, the gravitation attraction force, which is known as weight of the object acting downward. In addition to the gravitation attraction force, there must be normal reaction force, which is given by the surface. Right? So let me use a different color pen and draw it. The reaction force given by the surface to the object. Right? Like this. And what is the mass of the object here? 4 kilogram. Please draw this figure. Please draw this figure quickly. So this is the friction force. So I use Fr. Fr Newton is the friction force acting on the object. Can you? I think you are able to see the board clearly, right? Then the weight of the object. Then the weight of the object should also be marked. Weight of the object is mg. Mg Newton. Sometimes it is called weight of the object, sometimes, but actually it is the gravitation attraction force given by the Earth. We call it as the weight, but the best term is the gravitation attraction force given by the Earth. Then let me mark the normal reaction force. The normal reaction force. Normally it is indicated as capital R Newton. Capital R Newton. So please mark them here. Quick. Draw the figure and mark the forces acting on the object. And they have given us the acceleration also. Acceleration of the object is given as 0.2 meter per square seconds. This is also given. Mark them already. There are two methods to find friction force. There are two methods to find friction force. Here acceleration is known. So as acceleration is known, I'll use the equation F equals ma. Look at board name. I'll use the equation F equals ma because acceleration is given, acceleration is known. Now somebody unmute the mic and tell me, I'm going to apply F equals ma along the horizontal direction. F equal ma along the horizontal direction. That's the point. Along the horizontal direction. Right. Somebody tell me how many forces are acting along the horizontal direction here.
Two forces.
Two forces. Are they acting in the same direction? No, opposite directions.
Opposite direction.
Opposite directions, sir.
Very good. They are acting in the opposite direction. They are the resultant force. It is the resultant force. Now resultant force is 6 minus Fr. Fr is the friction force. Equals mass of the object is given as 2 kilograms. Acceleration is given in the equation as 0.2. Acceleration is given as 0.2. Can you do the rest of the simplification and tell me the answer here? And send your answers to Zoom chat. Please do the rest of the simplification. Send your answers to Zoom chat. From this equation, you can find Fr. Fr means friction force. Send me the value of friction force. Start. It's so simple, right? So I'm not going to do anything to 6. Actually, we can't do anything to 6. And we cannot do anything to Fr equals 4 into 0.2. 4 times 2, 8. But there should be a decimal place. So it is 0.8. 0.8. Right? So next step, I'll take this 0.8 to the other side. Plus 0.8 comes to the other side as minus 0.8. Minus Fr goes to the other side as plus Fr. 6 minus 0.8 means 5.2 equals Fr. but we never keep an answer like this. We should keep the answer as if our friction force equals 5.2, then we should write the unit. So we should always keep the answers in this format. If R equals something, we do not write a number equals F1. That's something. That's really complete here. Who got this answer? If R equal 5.2 Newton, Lamai? Right. What's the other equation? What's the other equation that can be used to find friction force? We have learned another equation to find the friction force. What is it?
Friction force equal to mu r.
Friction force equal mu r. Mu is a constant. What's the name of the constant? What's the name of the constant mu? It is called coefficient of friction. What is it called here? Lamai?
Coefficient of friction, sir.
Very good, coefficient of friction. Here, look at board here. Who gives this mg force? Who gives this simple mg force? Let's say this object is kept on a table. Let's think this object is kept on a table like this. Table is kept on the earth. Who gives this simple mg force?
Earth, sir.
Earth, very good. Simple mg force is given by the earth. Who gives capital R force here?
The surface.
The surface of the table. The surface of the table. If R force is larger than mg force, what will happen to the object? Will it be moved or not? Sorry, dear?
The object moves upwards, sir.
Very good. If capital R force is larger than mg, the object will be moved up. If mg force is larger than R, Lamai, what will happen?
The object moves downwards.
The object moves downward. If mg force is larger than R, it will be moved downward. If R and mg are equal,
The object will be at rest.
it will be at rest. So object will not be moved upward, object is not moving downward, it is moving only along the horizontal direction. Therefore, R and mg forces should be the same. Star point at right. Star point at right. There is no motion along the vertical direction. Star point at right. There is no motion along the vertical direction. Therefore, there is no motion along the vertical direction. Therefore, upward force should be equal to the downward force. There is no vertical motion. Full stop. Therefore, upward force should be equal to the downward force. Right. So leave a line and write. Then upward force is R, downward force is mg. So R equals mg. So m is 4 kilogram, g is 10. 4 times 10 is 40 Newton. Got it here? So we have found the normal reaction force. Complete it. We have found the normal reaction force. Normal reaction force is given by the surface on which the object is kept. Okay? The normal reaction force is given by the surface on which the object is kept. Okay, dear? Capital R is the normal reaction force. Capital R is the normal reaction force which is given by the surface on which the object is kept. capital R is the normal reaction force given by the surface on which the object is kept. Kept, K-E-P-E, kept. Right now, I'm going to use the second equation for the friction force. Friction force equals mu r. I use the English letter U to indicate mu because I don't have any other way. I don't have Greek letters in this keyboard, right? So we have already found that friction force is 5.2 Newton. Mu we don't know. R is 40, right? So by using this equation, we can find the mu. I have indicated English letter U, but it's, you should use the Greek letter mu for it. Can you find the value of mu and send me your answers to the group chat here? Zoom chat. So if you take 40 to this side, let me take 40 to this side. So multiplication 40 come to this side as division 40. So 5.2 divided by 40. 5.2 divided by 40 equals mu. Got it? So what can we do here? How do we simplify this? The easiest method is this. Look at board here. I can divide 5 by 4. 5 divided by 4 is 1 point. 5 divided by 4 is 4. 5 minus 4 is 1 remains. Then 12 divided by 4 is 3. So if I divide 5.2 by 4, answer is 1.3. If I divide 40 by 4, answer is 40 divided by 4 is 10. Sorry. So what have I done here? I have divided both 5.2 and 40 by 4. Okay. Then 1.3 divided by 10 is 0.13. So mu is known as the coefficient of friction. We have found it answer as 0.13. What's the unit of mu here? Somebody unmute the mic and tell me what is the unit of mu?
No units.
No units.
No.
Very good. No units. No units. Somebody please unmute the mic and read the question once again. Question number 12. Somebody please unmute the mic and read one more time.
An object of mass 4 kg is moved on a rough horizontal surface with constant acceleration of 0.2 meter second minus 2 by the horizontal force of 6 Newton.
Thank you, dear. Thank you very much. An object of mass 4 kg is moved on a rough horizontal surface with a constant acceleration of 0.2 meter per square seconds by a horizontal force of 6 Newton. So what are things that they have asked? As I remember, they have asked us to find the coefficient of friction. And as I remember the things that they have asked. Yeah, the coefficient of friction. Find the coefficient of friction and find the friction force acting on the object and the coefficient of friction. So what are things that they have asked? I think you can barely read this question. Find the friction force acting on the object and the coefficient of friction. Okay, dear? Right. So the complete answer to the question is here. If you want, please take the screenshot. If you want any more time to write the answer, please take the screenshot. The complete answer is here. Okay, shall we go to question number 13 also? I think it will be a help if I discuss question number 13, because sometimes you may have forgotten about the tension forces in a string. May I discuss question number 13 also, or are you okay with it? No answers. Right. I'll list everything and I'll go to question number 13. Right. But I'm not going to discuss more than question number 13. I'll go to another section just after I discuss question number 13. Right. I use the letter U for the instead of mu because I do not have the letter mu in my keyboard. As I cannot type mu, I use the English letter U. So if you are really upset with it, just make it mu by drawing a line like this. If you want. Okay, those things are not problems, right? Right. Let's go to question number 13. Right. Somebody unmute the mic and read question number 13. Start there. Read all the things, all the questions, including Roman numbers.
Two objects are connected by a light inextensible string and they are moved on a smooth horizontal surface by a horizontal force as shown in the figure. Roman 1. Find the acceleration of the system. Roman 2. Draw the free force diagram of the object and the string. Roman number 3. What are the tension forces acting at the end of the string?
Right. Thank you, Buddha. Two objects are connected by a light inextensible string and they are moved on a smooth horizontal surface by a horizontal force as shown in the following figure. Find the acceleration of the system. That is a very simple question. We can find the acceleration at once. Look at board. Let me draw the figure. 600 questions Tute. All the 600 questions are new questions. 600 questions Tute. Page number 3. Page number 3, question number 13. They have given us two objects. Two objects are there. Look at board. They are connected by a light inextensible string, massless, unstretchable string. They are connected like this. They are pulled on a horizontal surface by a horizontal external force of 18 Newton. The masses are given as 3 kilogram and 6 kilogram. Please draw this figure here. Write the heading 600 questions Tute. Use the normal theory note, right? You can use your theory note, no problem. 600 questions Tute, page number 3, question number 13, and draw this figure. Right? Due to this 18 Newton force, the whole system, all the things are moved with an acceleration of simple A meter per second. The first thing we want to find the size of A. The first thing that we want to find the size of simple A, acceleration. Draw it there, quick. listen here, we have sent some tubes free of charge. We didn't take. But there's a small problem with the 600 frictions tube. So let me show you the tube. See, this is the 600 questions tube. It is bigger than 2 CR books. That's the cases. See, if you check the size and weight, it's bigger than, you see, it's bigger than 2 CR books. So it takes a cost to print as well as it takes some money to post. But if you find, so therefore, and the other thing, and the biggest problem is these days it's difficult to print this one. Right, we have posted first, I think about first 100 I have given, and I have only few of these tubes, so we have to reprint. We have a small problem with the printing also. So please give us some more time. Please give me some more time to send you this tube. Right, shall we go to the next? No. Acceleration. How do you find acceleration, Kuda? Somebody please give me a method to find the acceleration.
F equals ma.
Very good. To the entire system, to the Lian, look at board on right. To the system, to this direction. What have I done here, dear? I have indicated to which that I apply the equation. What did I do here? Lian depa, bodepa. What did I done here? I have indicated to which that I apply the equation, and I have indicate the direction. Why should we indicate the direction with an equation? Tell me, dear.
So because it is a vector quantity.
It's a vector quantity.
Very good, because F is a force, a vector. Acceleration, it's a vector. When we work with vectors, when we deal with vectors, we must indicate the direction. That's the reason. If you consider this everything as
Because of it is vector quantity.
very good. If we consider everything as a single system, what is the only force acting on the system? This dotted line, the things inside this dotted line margin is said to be the system. So what is the only force acting on the system, dear? Somebody?
So the external force.
80,
External force.
yeah, what is it?
18 Newton.
18 newtons.
18 Newton, 18 Newton.
Force.
What is the total mass of the system?
9
9
kilograms.
kilograms.
9 kilograms.
Kilogram.
So 18 equal 9 times 8. Take 9 to this side. 18 divided by 9 equals 8. Therefore, acceleration is 2 meters per square seconds. 18 divided by 9 is 2. I know maths very well. I can divide 18 by 9. So acceleration equals 2 meters per square seconds. Write it. Write them all. Right. If we have written them, now we are able to draw the free body diagrams. Free body diagrams mean we mark all the forces acting on each object, even on the string. What is the free body diagram here? Free body diagram is a figure on which we mark all the forces. What is a free body diagram or a free force diagram? It's a figure on which we mark all the forces. Right. Look at board carefully. Do not write anything. Do not write anything. Look at board very, very carefully. Now, if we consider this, 6 kg object, why is it moving to right hand side? Why is it moving right hand side with an acceleration of 2 meters per square seconds? Somebody unmute the mic and tell me.
Because its force is in the right hand side. Greater
Again?
force.
Again? Yeah.
Because its force is in greater force is in the right hand side.
What is that force, dear? What is that force?
External force.
External force. Because of the 18 Newton external force, this object is moved to the right hand side with an acceleration. Who has said us that a force is needed for an object to be moved with an acceleration? Who said it? Who said
Newton,
Newton.
sir.
Newton had said that an object wants a force to be moved with an acceleration by his first law and second law. Right? Second law says F equals ma. Now, if I consider this string, why this string also move to the right hand side? Somebody unmute the mic and tell me why it is moving to right hand side. What are the reasons? There are two
Because
reasons.
it does
Yes.
not have.
Actually, there are two
So because
reasons.
it does not have a mass.
No, even it has a mass. Yeah.
Because of the external
The
force.
6 kg
What
object
are
gives
the real
force.
reasons behind it? Why it is moving right hand side?
The 6 kg object gives a force.
The first thing, the 6 kg object is connected to the string. So when the 6 kg object is moving right hand side, is string will also be moved with it. That's the reason. Am I right? 6 kg
Yes, sir.
object is
Yes,
connected
sir.
to the string. When the 6 kg object is moving, it has to move the string also. Am I right?
Yes, sir.
Yes, sir.
The first reason is 6 kg object and string are connected. When the 6 kg object is moving to the right hand side, the 6 kg object gives a force of T1 Newton to the string. The string is moved due to this T1 force. This T1 force is given by the 6 kg object. Now somebody unmute the mic and tell me Newton's third law of motion.
Every
Every
action has
an
an equal and opposite reaction.
Every action has equal and opposite reaction. Every action means every force has equal and opposite reaction force. When the 6 kg object gives a force of T1 to the string gives equal and opposite reaction force of F1 to the 6 kg object. This T1 and F1 equal in magnitude, opposite in the directions. Opposite in the directions can be seen. Equal in magnitude means if T1 is 100 Newton, F1 will also be, if T1 is 100 Newton, F1 will also be Hey,
100 newtons.
100 Newton. They are said to be action reaction forces. Action reaction forces. Now, let's come to this 3 kg object. Let's consider this 3 kg object. Right. Somebody unmute the mic and tell me the reasons. Actually, there are 2 reasons for the 3 kg object to be moved to the right hand side with an acceleration of 2 meter per square seconds. Why this 3 kg object is moving right hand side? There are 2 reasons. Somebody please tell me.
It is
Because
connected.
Yeah,
Because
because
it's
3
connect-
kg object and string are connected together. That's the first reason. Why? 3 kg object and the string are connected. Second reason, three kg object and the string are connected. That is the first reason for the 3 kg object to be moved. Second reason.
String gives a force.
Yeah, when the string is moving to the right hand side, it has to move with the 3 kg object. Therefore, the string gives a force of simple F2 to the 3 kg object. So 3 kg object is moved by F2. F2 is given by the string. Now tell me Newton's third law of motion. Newton's third law of motion.
Every action has
Every
equal
action
and
has
opposite
opposite
reaction.
Every action has equal and opposite reaction force. All the forces have oppositely directed force. So let me mark this force as T2. F2 given by string to the object. T2 is given by object to the string. They are equal in magnitude, opposite in the direction. Therefore, they are called action reaction forces. Action reaction forces. Right. Now, if F2 is 10 Newton, what should be the size of T2, dear?
10 Newton.
It should also be
10 Newton.
In addition to all of these forces, another 2 special forces are acting on 6 kg object. What are the 2 forces?
Gravitation.
Normal reaction force.
Gravitation acts.
Very good.
Reaction force.
Reaction force. Let me mark it as M1G Newton, and the normal reaction force given by the surface, let me mark it as R1. Similarly, there should be the same 2 forces acting on this 3 kg object. What are the 2 forces, dear? What are the other 2 forces acting on this 3 kg object?
Gravitation force.
Gravitation attraction force and
Gravitation attraction force M2G Newton and the normal reaction force R2 Newton. So these diagrams are said to be no free body diagrams. Why didn't I mark mg for the string? Somebody please tell me. Why didn't I mark m3g Newton for the string? Why is that?
It is a light object, sir.
It is said that light
The string is the
light
light
object.
string, no mass.
No
This string
mass.
does not have a mass, so there is no weight. I didn't draw an R force for the string. Why is that?
because
Because the string is
Because
not
it has
kept
no
on the
reaction, normal
surface.
reaction.
The string is at above the surface. As it is not in contact with the surface cannot give a reaction force. Object is on the surface, so surface give a force. 3 kg object is in contact with the surface, therefore the surface is giving a reaction force. But the string is not in contact with the horizontal surface. Therefore, the surface does not give any force to the string. So I didn't mark R on the string. Correct? So please draw the 3 figures. If you have any further doubts, please ask me. And never draw figures when I am explaining. Right? I'll give you more than enough time to draw the figures. Start here. while you are drawing figures, you can send me messages and ask doubts. Start. Once you have drawn the figures, please tell me, right? Send me a message saying that you have drawn it. So I think time is enough to draw. And if you are a new student, you must understand everything because I have explained everything from the beginning. But still, if you think you want to learn the missed sections, Send me a message. I'll add in some repeat classes, right? I am always support you if you really want to learn. Sometimes replies may be late, right? Resolution. Replies may be late, but I'll help you definitely. So if you think that you want additional help for the things that you have missed, if this is your first day or if this is your second day, so no problem, send me a message, I'll help you. I'll add some repeat classes, right? So I want to find this F2 and T2. To find F2 and T2, the easiest method is, look at board. Only to 3 kg object, please clearly indicate, only to 3 kg object into the right hand side horizontally. Let's apply F equals MA. The only horizontal force acting on the F2 object is 3 kilogram. The only horizontal force acting on the 3 kg object is F2. F2 equal mass is 3, acceleration is 2, so F2 equals 6 Newton. Got it? Right. My Dati's daughter is there. She is helping me a lot to teach you. Say bye. Okay, now. Okay, shall we please find 6 Newton, and somebody unmute the mic and tell me if F2 is 6 Newton, what should be T2, dear? Sorry, what should be T2, dear? You can't unmute me. Wait. I'll give you a help. Right now, somebody please tell
6
me. Unmute the
Newton.
mic
6
and tell
Newton.
me.
Newton, sir.
Yes, very
6
good.
Newtons.
Very good. But we know that F2 equals T2. So if F2 is 6 Newton, T2 should also be 6 Newton. So this T1 and T2 forces, are said to be tension forces in the string. Complete it here. Mark it. And the other thing is, I'll not stop online classes, right? I'll continue online classes until you go to the examination. And the other thing is, according to this present situation, we don't know whether we'll be able to start physical classes or not. The online, this Monday, this Tuesday night class, I'll not stop until you go to the examination. We'll continue all the online classes until your examination. Not only me, the math teacher and chemistry teacher will also do the same. So don't worry, right? Okay, dear. Now, how do we find this T1? Somebody unmute the mic and tell me. If we know F1, we can know T1. So how do we find this F1? Somebody please tell me a method.
Applying F equals ma only to 6 kg.
Very good. Only to 6 kg object. Only to 6 kg object. Let's apply F equal ma equation horizontally. I have indicated the object. I have indicated the direction. How many horizontal forces are acting on the 6 kg object? How many horizontal forces?
2.
There are
Two,
two
sir.
horizontal forces, F1 and Fex. The resultant force acting on the 6 kg object is Fex minus F1. Equal mass is 6, acceleration is 2. Can you do the rest and find F1, dear? Can you do the rest and find F1? Give a try. Try, dear. Right. Okay. Right. Right. Let me take this plus 12 to this side. 18 plus 12 come this side as minus 12. Minus F1 goes to other side as positive F1. 18 minus 12 is 6. So F1 equals 6 Newton. Who got this answer? But we know that F1 equals to T1. Therefore, T1 is also 6 Newton. So what do you think about this T1 and T2 forces, Deep? T1 and T2 are the tension forces acting on the string. The names of T1, T2 tension forces. Now you see that T1 and T2 are equal. Both T2, T1, 6 Newton each. Remember that the tension forces be equal only when the mass is 0. If it is given that string is massless or string is light, then only the tension forces are equal. If the string has a mass, the tension forces will not be equal.